So in the diagram to the right, choose all that apply. Line P can also be called line CD. And I can see here that line P can also be line DC. It can also be CD. So that's a check. Line P can also be called CP. It cannot, even though line P has the lowercase cursive p, that does not indicate a point. Line P is coplanar with line AB. So this line here and this line here are in the same plane. So that is true. So we had this one, we had this one. A, B, C, D. A, B, C, D are all coplanar. They're all in plane G, that's true. Line E, that's this line, intersects line N at point B. That's true. Another name for plane G is ABD, and that is true. A plane can be named by 3 non-collinear points. So that is correct. Moving on to the next question. Which of the following is not a possible name for the intersection of the two planes shown at the right? So I can say that this green plane and this blue plane intersect at this line. And we're going to do this more in chapter 2, but two planes can intersect in a line. So I can call that, I can't call that line P. This is plane P, not line P. I can call it line AB. I can call it BA. I cannot call it plane Q because it intersects at a line, not at a plane. Intersection of the plane would be literally if the planes were like right on top of each other. So I think I skipped number 3 here. I did. So given that x is between j and l, solve for the variable, and on yours it said xy, I think. We're going to do kl. So we're going to actually be able to see behind these images so that there's writing there and that you can actually read my handwriting. So if my former students from Florida are looking at this video at all, they're jealous because they had to deal with my bad handwriting, but I'm getting all fancy here and we're using magic ink. So the first thing I would say is to draw a diagram. I have J and L is a line segment with point K somewhere in between. So I drew a line segment. I labeled the endpoints of the segment J and L, and I put K somewhere in between. So now I can set up this equation. So J to K is a segment. K to L is a segment. If I add them together, I get the entire segment JL. Talk about this more in chapter 2, but this is the segment addition postulate. So now I'm going to substitute in some values. I have that JK is equal to 2x. And I have that KL is equal to x plus 2. And I have that JL is equal to 5 minus 10. That's substitution. So now I need to solve. So the first thing I would do, I would combine my x's, and I would get 3x, bring down the 2, equals 5n minus 10. So I'm combining like terms there. Now I would subtract 3x from the 5x to get 2x. And I think I have this not written here for a little bit. So I would subtract 3x from 5x, that would give me 2x. I would add the 10 on both sides, so I would end up getting 12 equals 2x, and x equals 6. But I was asked to find the variable and solve for KL. So the last thing I have to do, I'm getting rid of some of this picture here. The last thing I have to do is I have to plug that back in. So substitute back in to solve for XL. So if XL equals X plus 2, and I substituted in that value 6 for 2, I would get that KL equals 8. So my answers, solving for the variable is 6, solving for KL is 8. Problem number 4, find the missing segment length. So here I can see the entire length, F to H is 15. That means F to G, which is 9.7, plus G to H is going to equal 15. So I'm going to set up an equation. F to G plus G to H is equal F to H. So I'm going to plug in some values here. They tell me that F to G is 9.7. GH is what I'm solving for. The whole thing equals 15. When I subtract 9.7 to solve my equation, I get GH equals 5.3. I did. So, I got really fancy with these. I'm very excited. We're going to ask to find the distance. So you want to be really careful when you get these problems to figure out if you're finding the distance or if you're finding the midpoint. So distance is the distance formula. We're actually using a length. Okay? So I can see right here that I'm going to be finding distance. Okay? And it says to leave your answer in simplest radical form. So I can see that I'm given two ordered pairs. I'm given C at -2, -1, and K at 8, 3. So sometimes we get confused about where to plug things in. So I make a little box here. And I'm going to write for my first number there, that first ordered pair was -2, -1. I'm setting it like this. So this is under my X column, this is my Y column, and this is my first pair. My second pair is 8, 3. It does not matter which one I list as my first pair or which one I list as my second pair. I tend to just put whichever one they gave me first. So now I'm going to substitute in some values. X sub 2 means the X value in the second pair. I look at my chart. The X value in the second pair is 8. Now I look at my X value in my first pair. The X value in my first pair is -2. And I can substitute those in. Now the same thing with my Y's. My Y in my second pair is 3. My Y in my first pair is -1. So now I can start combining. 8 minus -2. Subtracting a negative is the same as adding a positive. That gives me 10. And 3 minus -1 is the same as 3 plus 1. That gives me 4. So now, 10 squared is 100. Plus 4 squared is 16. I think the answer said, the question said, leave my answer in simplest radical form. So right now I'm at 116. I want to try and see if there are any perfect squares that are factors so I can simplify this further. So since I have an even number, obviously an even number is divisible by 2, but since 2 is not a perfect square, that's not going to help me. So one of the first things I do is I take my calculator. Whenever I have an even number, I say, let's see, is it divisible by 4? And in this case it is. I get that 116, the factors of 116 are 4 and 29. And now I have some perfect squares. Since 4 is a perfect square, the square root of 4 is 2. 29 is a prime number. There's nothing else I can do with it. So it's 2 square root of 29. did this in some of the classes. If I were actually to figure out what 116 was as a decimal, it's 10.77033. Okay, or that's going to round to 10.8 roughly. If I were to take the square root of 29 and multiply it by 2, I get the same thing. So these numbers as a decimal end up being the same thing. When we say simplest radical form, we're basically just asking for the smallest numbers. Problem number 6 is a midpoint formula. So find the coordinates of the midpoint. That means my answer is going to be x, y. So the first thing I do is I make sure I know what I'm going to use for my first x, or my x sub 1, and my x sub 2. So the first ordered pair, the x value is negative 12, and the y value is negative 7. And for my second ordered pair, negative 8, negative 4. So I have over here the midpoint formula. So remember, finding the midpoint and finding a point. I'm basically saying I have a line segment with one coordinate at negative 12, negative 7 on a coordinate grid, and one coordinate at negative 8, negative 4 on a coordinate grid. I want to know what's in the middle. So I'm going to set up these values. X sub 1 is negative 12, x sub 2 is negative 8. Y sub 1 is negative 7, y sub 2 is negative 4. Negative 12 plus negative 8 is negative 20. Divided by 2 is negative 10. Negative 7 plus negative 4 is negative 11. Divided by 2 is negative 11 squared. And that is the answer.